For problem 2, we have the figure, which I tried to recreate in this page. And we notice that we have a current going through the circle. And if we look at what sources we have the source E, and that source is also going through the internal resistance little r and the resistance capital R, and that's going to do a voltage drop of I little r and I big R, and that has to equal 0. If we add all of these sources up between the source and the voltage drops, that has to be 0 in a closed circuit. So this is the same as saying that E minus I little r plus big R equals 0, or that I by itself is the source over the sum of the resistance values. And we're given that this is 12 volts over 2 ohms plus 4 ohms, which gives us a current of 2 amps. And then the voltage, if we look at the voltage across the nodes I prime and B prime, that's going to be the current times the resistance through those. So this is 2 amps times 4 ohms, which is 8 volts. And likewise, if we look at the voltage that's going through the small resistor, that would be VAB, which is the source itself minus the voltage drop across the internal resistance, which is going to be 12 volts minus 2 amps times 2 ohms, which also gives us 8 volts. So you see that there's a consistency between what is happening inside and outside that value of the internal resistance. Now we're asked to find, so let's consider this to be part A. Part B is asking, find the rate of energy conversion. So the rate of energy conversion is the power, and the power is given by the source voltage times the current, which is 12 volts times 2 amps, or 24 watts. The energy dissipation, it's also a power. Let's call this P sub source. Let's call this P sub little r for dissipation, because we're losing that power, is going to be the current times the resistance, the current squared, times the resistance. And if we plug these in, we get 2 amps squared times 2 ohms, which is 8 watts. And now we can find the power across, if you want, a node A prime, B prime, which is where the voltage would be for the net power, that can be set as the voltage across those two times the current, like we did earlier. That voltage was 8 volts. The current is 2 amps. So this is 16 watts. And finally, if we want to find the power dissipation through the resistor, capital R, that's going to be I squared capital R, which is 2 amps squared times 4 ohms, or 16 watts. So notice that these are also the same. So just depends when you're looking for power. It's going to depend on what element of the circuit you're using in order to find those power dissipations or conversions.